Assalamualaikum warahmatullahi wabarakatuh, and good day to all panels and viewers. My name is Annasuhah Azlan, and I will be presenting my final year project on effects of partial remelting on microstructures and mechanical properties of THIXOFORMED aluminium alloys. And I am under supervised by Associate Professor in Senior Technologies Dr. Muhammad Syukur bin Saleh. As introduction, I have been using aluminium alloy of A308 or LM21 type for this project. It is a cast alloy that has good mechanical properties, and for the billet preparation, I have been using a stir casting process to make the feedstock preparation. The duration was 5 minutes stirring, and it is to enhance the mechanical properties of the metal matrix composition. And the next process that has been used was THIXOFORMED process for the SSMP with the purpose of to reach the non-dendritic microstructure. And the last process was the heat treatment process that I used was T6 heat treatment, and it is to improve the mechanical properties of the material. There are three objectives for this project, which are firstly to produce aluminium alloy for THIXOFORMing using partial remelting, and then to investigate the microstructural evolution of aluminium alloy after partial remelting, and next to determine the mechanical properties of THIXOFORMed aluminium alloy. And the scopes of this project are stir casting technique, and then the THIXOFORM to eliminate non-dendritic microstructure, then treated with T6 heat treatment, and then the microstructural analysis by using scanning electron microscope, and of course mechanical properties of the materials by using the viscous hardness and universal tensile machine. The problem statements of this project are less previous research on A308 because infamous type of industrial uses on the material. Next, THIXOFORMing process, relatively time-consuming process and high energy process. And last but not least, the effect of T6 heat treatment on aluminium matrix when undergone the THIXOFORMing process. For the review, A308 aluminium alloy was taken as an experimental alloy due to its availability and better stability. The A308 alloy has not been commercialized yet due to a lack of improvement in the mechanical properties. However, an effort has been made to control the microstructure along with the improvement in metallurgical, physical and also mechanical properties of A308 alloy by using horizontal mold vibration for the use of automotive components. This was extracted by Patel et al. 2014. And next, stir casting is a method where reinforced particulate is blended homogeneously into aluminium matrix, mechanically stirring at high rotational speeds. After that, the molten metal is directly transferred to shape mold for solidification. And THIXOFORMing improves the mechanical properties of A308 material, especially the yield strength and the tensile elongation compared to the permanent mold casting. And of course, hardness increased due to extremely low porosity and fine size of the alpha aluminium grain throughout the sample. For the UTS, ultimate tensile strength of THIXOFORM T6 part increased by 22% than THIXOFORM parts and 41.9% than S-cast A308 alloy. This was extracted by Sharma et al. 2017. Semi-solid metal processing. This is the key element in the SSMP in the globular microstructure rather than dendritic microstructure, and it is the thixotropic behavior of the semi-solid slurry which reduces the segregation and porosity in the castings. Compared with conventional techniques, SSMP provides several advantages like higher product quality, lower forming temperature, higher production rate, and improvement of the mechanical properties through microstructural refinement. And THIXOFORMing is one of the member of SSMP routes based on the thixotropic behavior of alloys with the non-dendritic microstructure in the semi-solid state rather than recasting route. Moreover, THIXOFORMing and related SSMP methods require thixotropic feedstock materials as starting material, and the figure shows schematic illustration of A. Recasting process and B. THIXOFORMing processes, and this was extracted from Mendel et al. 2014. Mechanism for formation of non-dendritic microstructure, and several mechanisms have been proposed to explain the presence of non-dendritic morphology, which involves the formation of the fine near-spheroidal particles through forced convection caused by stirring, as stated by Fleming's 1991, Kirkwood 1994, and Fan 2002. One mechanism which distinguishes semi-solid metal slurries from other suspensions is that the particular shape and size vary irreversibly with time. The mechanism for dendritic fragmentation, which may be divided into major groups, is shown in the figure above and extracted by Wong et al. 2011. For the design experiment that I used to make a total of 10 billets, by using stir casting, I had cooked for every cook 400 gram of ingot used, and it must be cooked until it reaches 700 degrees Celsius, which was the melting point of the aluminium alloy, and then it will be poured directly into the mold. And after it reaches 10 billets, I went to THIXOFORMED process for my first objective in this project by using 8 billets and leaving the other 2 billets for the S-cast samples. And for the THIXOFORMED process, the measurement needed for the billet was 11 cm. To fit the place in the cold induction, and the temperature of compress was 502 degrees Celsius. And during this process, I have to avoid the situation of elephant foot happened to my specimen. As I have finished and I reached 8 billets of the THIXOFORMED process, I divided samples into 2. So there would be 4 samples for THIXOFORMED process and other 4 samples for the upcoming T6 heat treatment process. And for the T6 heat treatment process, there were 3 steps included. Firstly, it was solution treatment. It must be held for 540 degrees Celsius and 8 hours of holding time. And then secondly, quenching process. It will be soaked. The sample will be soaked into the room temperature water for about 5 minutes. And lastly, I have to undergo again to put in the furnace. It's called the AG process. It must be held for 160 degrees Celsius for 4 hours holding time. And then for the microstructural investigation, SEM or scanning electron microscopy as the second objective was by applying 150 times for the magnification, and I observed the overall morphological state of the samples for the S-cast, for the THIXOFORMED and the THIXOFORMED heat-treated samples. And next, for the mechanical testing, I used the tensile testing, which is the UTM, Universal Tensile Machine, and the samples were prepared firstly by using the CNC turning machine with ASTM E8M standards, and also hardness Vickers by using ASTM E384 standard, which were my third objective. So from here, for the microstructural analysis, by using the SEM is to identify different phases of the sample or microstructural evolution. And the mechanical testing, hardness test, I used the Vickers hardness test, and by using the ASTM E384 standard. And the tensile test, I used the UTM by using the ASTM E8M standard. As we can see here, there are 3 figures. First of all, figure A for S-cast, figure B for THIXOFORMED, and figure C for T6 heat treated. And we can see that there are dendritics formation in figure A. We can see that more branches of dendrites. And as for figure B for THIXOFORMED sample, this is a rosette shape, and it has near spheroidal formation to near globular but not yet globular. And we can see that there are many rounded shape of eutectic silicon. And for figure C, the T6 heat treated, it has formed a globular shape, and the grain boundaries formation in between the grains, and rounded shape with bigger size of alpha aluminium. So we have see much more globular shape. Okay, and First of all, stir casting process in figure A produce superior non-dendritic feedstock for THIXOFORMED, so it must be able to produce homogeneity in the microstructure. And the changes in the microstructure features after stir casting is observed, which is when the THIXOFORMED process, and alpha aluminium was transformed completely from dendritic to near globular or near spheroidal after THIXOFORMED. And dendritics are the effect of stirring time during stir casting, and I assume it needed longer time, more than 5 minutes, to produce more globular shape as from previous research. And a near spheroidal, which is alpha aluminium phase, appears in figure B in THIXOFORMED process, show that this process is better than conventional forming process. Okay, for the figure C, short T6 heat treatment affected eutectic silicon, eutectic morphology in the figure C, and the eutectic silicon particles spheroidized, acquiring a more rounded shape and increasing significantly in their size. So for the mechanical testing, hardness testing, I use the indentation force for 1 kgf and the loading time for 10 seconds for overall total 0.49, and then these are the average for every 9 points for every sample as cast, THIXOFORMED, and short T6 heat treatment. And and from the table above, we can see that the trending line is increasing, and the increased hardness of the THIXOFORMED after T6 heat treatment sample was due to the extremely low porosity, and the size of alpha aluminium grains throughout the sample has been increased, as we can see from before the microstructural evolution. So we can say that the increase in the measurement can be attributed through the precipitated of an intermetallic phase among the alpha aluminium globules in the alloys. So since the measurement shows increasing of 4.05% in hardness after T6 heat treatment process. Next, the tensile test, the ultimate tensile strength and the yield strength, and of course the elongation to fracture of S-cast, THIXOFORMED, and THIXOFORMED T6 are as follows. The trend line of these three results are also increasing, and the THIXOFORMED is a well accepted method for enhancing the mechanical strength of thixotropic aluminium alloy by reducing or eliminating the porosity defect and enhancing the chemical homogeneity. But then the results show significant improvement percentages of A308 aluminium alloy rather than S-cast. However, the T6 heat treatment shows the highest results of all three for the UTS, YS, and elongation through fracture, as it attributes the ductility properties better than the THIXOFORMED and the S-cast samples. Same as before, for the fracture to elongation, T6 heat treatment shows the highest value. As conclusion, the THIXOFORMED process and T6 heat treatment had eliminated the dendritic microstructure, and T6 heat treatment formed a globular microstructure. Secondly, the highest hardness obtained was from the T6 heat treated sample, and the highest ultimate tensile strength obtained are also from the T6 heat treated sample. Thirdly, the morphology properties of THIXOFORMED significantly improves after T6 heat treatments, and T6 heat treatment leads to the best results in morphological properties as well as the mechanical analysis. As an improvement, to increase the mechanical properties and morphological structure, it is recommended to add reinforcement elements in the materials. That's all from me. Thank you.